The next frontier in renewable energy isn't solar. It isn't wind. It's the ocean. Right now, off the coast of Oregon, the US government is quietly building something extraordinary. PacWave, America's first grid-connected wave energy test site. And if it works, the waves crashing on US shores could power millions of homes, day and night, year-round, no matter the weather. This is the story of PacWave, CalWave, and how the US might finally tap the one renewable we've barely touched, the sea. What is PacWave? PacWave is a groundbreaking marine energy test site, backed by the US Department of Energy and strategically located off the central coast of Oregon, just a few miles from the port city of Newport. More than just an experimental zone, it represents a major leap forward for the future of ocean-based renewable energy in the United States. This facility is the first of its kind in the country, a fully grid-connected wave energy test site designed to accelerate the development, validation, and commercialization of wave power technologies. That means companies and researchers can plug directly into the power grid, allowing real-world data on energy output, system performance, and reliability. PacWave is purpose-built to support full-scale, multi-megawatt wave energy converters. These aren't prototypes floating in isolation. They're real machines, facing real waves, generating real electricity. Whether you're a startup, chasing a radical design, a university testing advanced materials, or a global energy developer refining your next-gen platform, PacWave is open for business. What makes it truly valuable is the infrastructure beneath the waves. A complex of underwater transmission cables, environmental monitoring sensors, and subsea connection points, all feeding into an offshore electrical substation. Real-time data analysis tools are integrated directly into the system, enabling engineers to measure how well these wave devices sync with the grid, minute by minute. In short, think of PacWave as the ocean's equivalent of a wind tunnel or rocket test stand. It's where ocean energy gets serious, where ideas leave the lab and face the surf. For the marine renewables sector, it's not just a test site. It's the proving ground for a clean energy future. Why wave energy? Because the ocean never sleeps. While the sun rises and sets and wind speeds fluctuate hour to hour, the ocean is always in motion. Tides rise, waves crash, and swells roll in relentlessly. That's what makes wave energy so uniquely promising. It's not just another renewable source, it's a different kind of consistency. Wave energy is fundamentally reliable. Unlike solar panels that go dark at night or wind turbines that stall on still days, wave systems can generate electricity around the clock. The ocean doesn't take weekends off. It's also highly predictable. We can model and forecast wave patterns with remarkable accuracy, days in advance. That makes wave energy easier to integrate into power grids and plan for in terms of demand and storage. Then there's the energy density. A single square meter of ocean can carry far more kinetic energy than a comparable area of wind or solar. That means you don't need vast stretches of land or thousands of acres offshore. Just the right technology in the right place. In the US, we're sitting on an ocean gold mine. With over 95,000 miles of coastline, the country is geographically positioned to become a global leader in marine energy. From the Pacific to the Atlantic to the Gulf, wave power potential is everywhere. In short, the ocean is a giant, untapped battery, one that recharges itself with every tide and storm. If we can figure out how to harness even a fraction of it efficiently, wave energy could supply up to 20% of the nation's electricity. Not a supplement, an energy revolution waiting offshore. Key takeaway number 1. PacWave makes commercial scale testing possible. Until now, wave energy in the US has been stuck in a kind of prototype purgatory. Engineers and innovators could build devices, test them in labs, or even deploy small-scale models offshore, but always with limitations. They couldn't test at full commercial scale. They couldn't connect to the actual electrical grid. They couldn't operate in high-energy, real-world ocean conditions over extended periods. PacWave changes all of that. This facility provides an unprecedented platform for innovation, bridging the gap between early-stage experimentation and market-ready deployment. It offers 4 grid-connected test berths, each capable of handling full-scale wave energy converters, with up to 20 megawatts of total testing capacity. Developers finally have the infrastructure to push their systems to the limit. A 7-mile, buried subsea cable system runs from the offshore site to an onshore substation, delivering clean energy directly into the Pacific Northwest power grid. That means no more hypothetical outputs, just real electricity powering real homes. The site is also modular and flexible, designed to accommodate multiple technologies and configurations at once. Point absorbers, oscillating water columns, hybrid systems, there's room to try them all. For the first time, developers can move seamlessly from lab to ocean to grid, a full pipeline for commercial-scale marine energy. And they are. PacWave isn't just open, it's already being used. CalWave's X-Wave success story. One of the most promising players in the wave energy race? CalWave Power Technologies, a California-based startup pushing boundaries with its innovative wave energy converter, the X-Wave. Unlike surface-floating systems that are vulnerable to weather, the X-Wave stays fully submerged beneath the ocean's surface, safely out of reach from violent waves and storm surges. It's a sleek, hydrodynamic design that moves with both heave, up-down, and surge, front-back motions of the water, capturing energy in multiple directions for maximum efficiency. This approach comes with serious advantages. By staying underwater, X-Wave avoids the brunt of storms, reduces wear and tear, and delivers stable, consistent power output, even when the surface is churning with chaos. Recently, CalWave completed a 10-month open water pilot in the coastal waters off San Diego. The system ran almost flawlessly, operating autonomously with minimal maintenance and producing a steady stream of energy through a wide range of conditions, from calm days to rough swells. That pilot demonstrated 3 major milestones: exceptional system durability, high energy conversion efficiency, simple retrieval and redeployment for maintenance. Now CalWave is taking the next big leap. The X-Wave is headed to PacWave, where it will undergo full-scale testing in a grid-connected environment. That means real electricity flowing into the system, real data, real stress tests, and real progress toward commercialization. This isn't science fiction. It's happening right now, beneath the waves. How X-Wave works. At the heart of CalWave's innovation is the X-Wave, a cutting-edge device known as a point absorber, a type of wave energy converter that captures power from both vertical, heave, and horizontal, surge motion of ocean waves. But unlike many traditional wave devices that float on the surface and visibly bob up and down, X-Wave is different. It's fully submerged and anchored to the sea floor, operating silently beneath the waterline. This clever design choice unlocks several critical advantages. First, it's less visible, which is a big deal for communities concerned with preserving scenic coastlines and avoiding visual pollution. Coastal tourism and energy development don't have to clash. Second, by operating below the surface, X-Wave is protected from the destructive forces of storms and high-impact wave events. This means longer operational lifespans, fewer emergency repairs, and lower long-term costs. Third, its position on the seafloor allows for easier maintenance using robotic submersibles. Instead of costly human divers or complex surface recovery, much of the servicing can be handled with autonomous underwater vehicles. And finally, all of this translates to higher uptime and more consistent power output. One of wave energy's biggest challenges now being solved. It's an elegant solution, durable, efficient, and purpose-built for real-world conditions. In a sector long defined by complexity and compromise, X-Wave represents something rare, a wave energy system that just works. Key takeaway number 2. DOE is betting big on wave power. The U.S. Department of Energy isn't just observing the rise of wave energy from the sidelines. It's going all in. In 2025, the DOE committed $25 million in dedicated funding for wave energy development, the largest single-year federal investment in this sector to date. It's a bold signal that marine renewables are no longer experimental curiosities. They're a strategic priority. This funding is designed to do more than just build devices. It targets the full ecosystem needed to move wave energy from pilot projects to commercial-scale reality. Grants will support the scaling of core technologies, helping startups and research teams transition from lab-tested concepts to full-scale deployments. Funding will also back environmental monitoring efforts, ensuring wave systems can coexist with marine life and fragile coastal ecosystems. Other investments include grid modeling to optimize how wave energy integrates with existing infrastructure, and workforce training programs to prepare the next generation of engineers, technicians, and ocean energy specialists. Crucially, the DOE is also encouraging international collaboration, recognizing that global partnerships can accelerate innovation and avoid duplication of effort. And with PacWave now operational, there's finally a world-class test site ready to receive that investment, where ideas can be tested, scaled, and validated in real ocean conditions. For wave power, this is more than funding. It's liftoff. The environmental case for wave energy. Wave power isn't just another renewable. It's one of the lowest impact energy sources available. And that's what matters in a world where clean energy must also be ecologically responsible. Unlike hydroelectric dams, wave energy doesn't block rivers, flood habitats, or alter water temperatures. Unlike offshore wind farms, it doesn't require towering turbines that disrupt bird migration paths or dominate ocean views for miles. Wave energy devices like X-Wave operate beneath the surface, quietly tethered to the seafloor. That means they avoid large visual footprints, don't interfere with coastal sightlines, and coexist more easily with commercial and recreational marine traffic. What about the marine ecosystem? Early research shows promising results. Studies indicate that fish, kelp, and benthic seafloor organisms adapt quickly to wave energy infrastructure. Some even benefit. The mooring systems and anchors can become artificial reefs, offering shelter and surfaces for algae and invertebrates to colonize, enhancing biodiversity rather than harming it. Additionally, these systems produce no emissions, no noise pollution, and no waste, making them ideal for delicate marine environments and coastal communities. Of course, long-term environmental monitoring is essential. But so far, the signs are clear. Wave energy can deliver power without disturbing the ocean it draws from. The ocean doesn't just provide power, it hosts it, nurtures it, and if done right, thrives alongside it. Grid integration. How will this power our homes? Wave energy, like all renewables, is variable. But unlike solar and wind, it's also predictable, and that makes it a powerful asset for modern energy grids. Grid operators don't just need clean power, they need a reliable, forecastable supply to balance real-time demand. That's where wave energy shines. Ocean conditions can be modeled days in advance, making wave output easier to plan for than gusty winds or passing clouds. At PacWave, this predictive potential is being fully realized. The site is building advanced infrastructure to support real-world integration, including real-time data feeds from each test device, tracking performance and energy output, forecasting models to predict wave energy production based on ocean conditions, connections to Oregon's coastal grid, linked clean power directly into homes and businesses. The long-term vision is even more exciting. Wave farms could power microgrids, localized energy systems perfect for island nations, remote coastal towns, and military bases that need resilient, off-grid solutions. Even more powerful is the synergy with solar and wind. Solar peaks during the day, wind often rises in the evening, but wave energy rolls in around the clock. Together, they can create a smooth, 24/7 renewable energy profile. In this scenario, wave energy isn't just a backup. It's the missing piece of the renewable puzzle, filling in the gaps, stabilizing the grid, and powering the transition to a cleaner, more resilient energy future. Key takeaway number 3. Commercial farms are coming by 2028 to 2030. The wave energy timeline isn't hypothetical anymore. It's real, it's active, and it's moving fast. The roadmap is already in motion. 2024 to 2025, finalize grid connections at PacWave, enabling full-scale, real-time power delivery. 2025 to 2027, test groundbreaking systems like CalWave's X-Wave in operational ocean environments, gathering performance data, proving reliability. 2028 plus, launch the first commercial wave farms in U.S. waters, real power plants, not pilots. 2030 plus, begin scaling wave power to support entire coastal communities and grid segments, adding resilience and clean capacity. This isn't some vague, far-off energy vision. It's a 6-year countdown to full commercial deployment. With PacWave online, federal funding secured, and companies already preparing for trials, the final pieces are falling into place. Coastal states like Oregon, California, and Hawaii are poised to lead, leveraging their wave-rich coastlines to generate power right where it's needed. The opportunity is massive. Wave farms could reduce reliance on fossil fuels, cut grid vulnerability, and supercharge America's clean energy leadership, all while creating new industries and jobs in coastal communities. The momentum is here. The tech is ready. The ocean is waiting. Wave energy's moment? It's now. The global context. U.S. playing catch-up. When it comes to wave energy, the U.S. isn't leading the charge, yet. Other countries have had a head start, building out infrastructure and piloting wave technologies for over a decade. Scotland is home to the European Marine Energy Centre, or EMEC, a world-renowned test site that has hosted dozens of marine energy devices since 2003. Portugal launched one of the first commercial wave farms at Agucadura, pioneering large-scale deployments in Atlantic waters. Australia has supported the long-term development of wave technologies through companies like Carnegie Clean Energy, with grid-connected trials off its west coast. And China is already operating nearshore systems, incorporating wave energy into broader renewable plans. In this global race, the U.S. has been trailing, lacking the infrastructure, regulatory clarity, and cohesive strategy to compete. But that's changing. With PacWave, the U.S. now has a world-class test site, built specifically to bring wave technologies from prototype to grid, backed by the Department of Energy, driven by private startups like CalWave, and supported by top-tier university research. From institutions like Oregon State University or OSU, UC San Diego, and MIT, the pieces are coming together. This is bigger than just clean power. It's about whether the U.S. will lead in the next generation of climate tech and ocean innovation, or watch from the sidelines. With the right push, America can catch up and lead. CalWave and the wave energy ecosystem. While CalWave has grabbed headlines with its sleek, subsurface X-Wave system, it's far from the only innovator in this space. A wave energy revolution isn't driven by one company. It's powered by a growing ecosystem of engineers, inventors, and startups, all racing to unlock the ocean's potential. Several companies are preparing to deploy and test their devices at PacWave, each bringing a unique approach to the same challenge: how to reliably, efficiently, and affordably harvest energy from waves. Oscilla Power is developing tethered point absorbers that use tension and motion to generate electricity. Aqua Harmonics, winner of a major DOE prize, is refining compact systems that use direct drive power takeoff. Sea Power focuses on small-scale, modular buoys that can power sensors, offshore platforms, and microgrids. DeHeesen Associates is working on hybrid systems and scalable solutions with decades of marine energy experience. Each of these designs reflects a different philosophy: floating versus submerged, single point versus distributed arrays, and mechanical versus hydraulic systems. PacWave provides the neutral proving ground, where they can be tested side by side, in the same ocean conditions, with the same grid infrastructure. It's not just a race, it's a shared learning environment. A place where breakthroughs build on each other, where competition drives innovation and collaboration fuels progress. Wave energy isn't one company's game anymore. It's a full-fledged ecosystem, and it's growing fast. What this means for the future. Imagine a world where the coastline doesn't just mark the edge of the grid, it powers it. Picture coastal cities running on the energy of the very waves that crash against their shores. Remote communities that once relied on expensive, polluting diesel are now powered by clean, silent, underwater generators. A national energy system that's more stable, more resilient, and less vulnerable to the peaks and valleys of wind and solar, because it's balanced by the deep, rhythmic pulse of the ocean. This is what the future wave energy makes possible, and with the right combination of technology, test infrastructure, and federal investment, it's not just a distant dream, it's on the horizon. Wave energy offers something rare in the renewable world: predictability. Combine that with innovations like CalWave's X-Wave, the infrastructure of PacWave, and the momentum of a growing industry, and the outcome becomes clear. Wave energy isn't just possible, it's inevitable. As PacWave comes online, it marks more than a technical milestone. It signals a turning point. The US is no longer watching from the sidelines. It's testing, investing, and deploying. It's catching up and catching on. The ocean has always moved us. Now, with innovation and intention, it might just power us. From a test site in Oregon, to a 10-month pilot in San Diego, to full-scale ocean farms by 2030, wave energy is real, it's here, and it's getting funded. Subscribe for more stories where cutting-edge tech meets environmental impact, and tell us in the comments, would you support a wave energy farm off your coast? Why or why not? Stay blessed and stay curious.